Hi, Vicky.
Hi, Shane.
So welcome to Third Pod.
Oh, thank you. I'm so excited to be here.
Yeah, so for those of you who are just joining us, you should go back a few at least. My former co-host Nancy has left us, but we still love Nancy.
Love
But
Nancy.
I'm very excited to have Vicky Thompson with us. So Vicky's one of my colleagues at AGU, and she's going to be my new co-host moving forward. And we're going to have a great time.
It's going to be so fun.
Yeah. To start off this great time, because, no pressure, I have a question for you.
Okay, shoot.
If an asteroid was hurling towards the planet...
Oh my gosh.
And you could do one last thing. No limitations. Like you could do one last thing. What would that thing be?
This is a hard question.
It is a hard question.
Yeah, because I have... So classic me, I have multiple answers.
Ooh,
but
okay.
I have one that I think is like the fun answer. I think actually I just want to have, the most perfect barbecue in your backyard with all of your friends, that kind of day.
Yeah.
That's what I want. Where it's just good food, friends, beer.
That's very nice.
Silly stuff. But I think what would actually I'd probably just lay down on the floor and cry. And that would be my last hurrah on Earth.
That was, I realized, I write most of these questions, but it's funny, I don't actually think about my own answers for that.
Sure. So what's on the spot?
Probably in line with your ladder. Yeah, I'd probably grab my partner and my dog and just lay and
weep,
cuddle and sob.
That's all.
I'd like to say it was something different, but probably not.
Well, really, what is the last thing that you do going to change?
Yeah,
anything?
Exactly. Just it's
There's
an
no
emotional
hope.
time.
Yeah, just lean into it.
Science is fascinating, but don't just take my word for it. Join us as we hear stories from scientists for everyone. I'm Shane Hanlon.
And I'm Vicky Thompson.
And this is Third Pod from the Sun. Well, so y'all might have guessed that we're talking about either the movie Don't Look Up, we've seen it, or, in our case, the extinction of the dinosaurs.
This isn't fair. This is not a good way for me to start my Third Pod tenure. Just doom and gloom.
Welcome, Vicky, to the podcast. We're going to talk about mass death.
Yes, yeah. Awesome.
I mean,
thank you.
Well, okay, so you're right. That is unfair. But here we are. So pushing forward.
It's real. Okay.
So there were 5. There's classically accepted that there were 5 big extinction events. And the one that wiped out the dinosaurs is, I'm not even going to say perhaps, it's the most well-known one.
Yeah.
Though, interestingly, not the biggest one. But since it's the one that everybody knows about and talks about, I figured this would be a great's doing a lot of work here. Good way to start our extinction series.
Yeah, it's definitely the most obvious way to start it, for sure. I think that places us all on the same page, but also it's dark.
It is dark.
Extinction is dark.
Extinction is dark, but we're gonna make it as. So the good thing is all the ones we're talking about have already happened,
right?
And we're gonna make it as fun and entertaining as possible. And so one thing folks will learn with not just extinctions, but a lot of things, is that I love to speculate wildly.
Ooh, me too.
I don't make any assertions of fact. I am a science communicator, but if I don't know something, I like to guess about it and then find out what the truth is. And that's kind of what I did with this extinction event. I think I know some things about it, but I then took the opportunity to chat with a couple of folks who knew much more than I did.
I'm David Mascato.
And I'm Will Harris.
And we are both paleontologists. We both got our masters in paleontology at East Tennessee State University together-ish several years ago. We've both done research in paleontology, mostly on reptiles and mostly on more recent stuff than dinosaurs and things like that. We are the hosts of the Common Descent podcast. a podcast about paleontology, evolution, and life history, and we are both affiliated with the Gray Fossil Site and Museum here in East Tennessee.
So we are here today to talk about the KPG extinction. And so as kind of a primer or a background for folks who might not be familiar with that terminology, can we just get a Cliff Notes version of when we say KPG extinction? What are we talking about?
Right. So the K stands for the Cretaceous period in sort of a circuitous way. And PG stands for the Paleogene period, which are the two periods on opposite ends of this geologic boundary at about 66 million years old, which marks the end of the Mesozoic era, the end of what we commonly call the Age of Dinosaurs. It is a boundary where, in the fossil record, we see the end of the record of most dinosaurs at the time, pterosaurs, mosasaurs, ammonites, lots of different groups of animals, also plants, marking a major extinction event that separates the Mesozoic era from our modern Cenozoic era.
That was the most recent major extinction if we are not talking about the Anthropocene, correct?
Yes.
Yeah.
So
Okay.
Geologists commonly talk about the Big Five, which are extinction events at the end of important time periods: the Ordovician, the Devonian, the Permian, the Triassic, and the Cretaceous being the most recent, what we refer to as a mass extinction, meaning, of course, that lots and lots and lots of things went extinct in a very short period of time.
And typically on like a global scale.
Okay, so yeah, that's what's going to be something I asked. There have been isolated extinctions of not just one species, but there have been isolated groups, whether that's on like a continent or whatever. That's not what we're talking about. It's like literally across the globe, or at least what our records have found across the globe.
Yes.
You mentioned that we were talking about 66 million years ago. This is the end, quote unquote, the end of the dinosaurs. If we're talking in millions of years, like how long is this period within that? Is it like 1 million years? Are we talking 100 years? Like how long was the actual extinction event, or at least what we know of it?
That's a great question. And the shortest answer is it's hard to say. Geologically short. So a mass extinction is complicated. A species doesn't go extinct overnight, and especially, hundreds and thousands of species don't go extinct overnight. Generally speaking, this extinction probably lasted a number of thousands, maybe tens of thousands of years, during which time ecosystems around the world were so interrupted and so disturbed that lots of different groups of organisms couldn't survive.
Okay, so yeah. Tens of thousands is much shorter than millions of years, but still within our human timeframes is quite long.
And in the geologic record, thousands or tens of thousands of years can be a blip.
Yeah. Can be very hard to actually detect time on that small a scale. So for our lifespan, you might not notice it happening. Were you alive during it? Because you wouldn't live long enough to experience it. But geologically, it just goes by in just a blink.
So just to give us some scale, you mentioned that 66 million years ago was like the end of this era of dinosaurs. What is commonly accepted as the beginning?
So the Mesozoic era starts at the end of the Permian, with the Permian mass extinction, which was even bigger and even worse. That was 250 million years ago. The earliest dinosaur fossils, the earliest true dinosaurs, show up around 230 million years or so. Dinosaurs really rise to prominence, like really become major players on the global stage, closer to 200 million years ago or so. So the Mesozoic starts 250 million years ago, which is almost 5 times older than the end of the Mesozoic at 66. The Age of Dinosaurs, if we want to call it that, doesn't really have an official beginning.
Nah.
But if we say it starts when dinosaurs really become a big deal, then it was probably 200 million years ago or so that started.
I love this idea of dinosaurs, quote unquote, becoming a big deal. I just can't imagine a time when dinosaurs were around where they weren't a big deal.
No, absolutely. I mean, I feel like kids are obsessed with them the second that they learn about them and then forever. So they are a big deal.
Yeah, it's weird to think about geologically. There were points in time when they were around and just weren't the dominating force out there. And so, yeah, just in kind of in the beginning of their, like when they popped up, I mean, it took a while for them to kind of, I don't know, not get with it, but really, really take over to become like the it thing.
Get their following going.
Get those social media followers.
Yeah. Get those clicks.
Yeah. And so I already kind of pleaded ignorance. I like that I was learning things during this interview and learning that whether or not, or frankly, when or not dinosaurs were the quote unquote it thing. And I also realized that I might not know what the literal definition of a dinosaur is.
So first of all, yes, dinosaurs is a term that it's like mammals or insects. It is a specific group of life that is defined by particular features.
Yes.
You know, some people think dinosaur and they think just any ancient animal that we've seen in a movie.
Yeah, especially if it's scaly.
Yes, exactly. Pterosaurs, which are the flying reptiles of the Mesozoic. Mosasaurs and plesiosaurs and ichthyosaurs, which were aquatic. Mosasaur famously featured in the new Jurassic World movies, so now very famous.
That's the giant one that jumped out of the water and ate was it a crane?
The shark.
It eats the shark.
It eats the shark.
And then also attacks a helicopter.
Yep.
Using the same
That's what
move.
I'm thinking of. Yes.
Yep.
Okay, all right.
So those are things that are not technically dinosaurs. They don't fit under that group of related evolutionary lineages.
Yeah, they're ancient reptiles, but of different groups. Some related to dinosaurs, some close cousins, but not actually in the group we would call Dinosauria.
That also includes crocs and alligators.
Yeah, those are cousins. They're on a branch off to the side, but not actually dinosaurs.
And then the point about what went extinct is actually really interesting, I think, because we call it the extinction of the dinosaurs. But on the one hand, lots of things went extinct that weren't dinosaurs.
Yep.
So we lost the last of the pterosaurs, mosasaurs. All those aquatic reptile groups didn't make it through to the end of the Cretaceous. Ammonites, the spiral-shelled cephalopods, cousins of octopus and squid, for example, did not survive this extinction. Lots of ancient mammals went extinct.
Yeah.
Lots of ancient reptiles, ancient amphibians, ancient plants. Basically, every major group of life was impacted to some degree by this extinction event. And the other reason why it's kind of funny that we think of it as the extinction of the dinosaurs is first that not all the dinosaurs went extinct. A small group of birds survived the extinction to give rise to our modern birds, and they do fit under the umbrella of the dinosaur evolutionary tree.
Yep.
And at the other end of things, most dinosaurs were already extinct when this happened.
Yeah.
So if you think about, dinosaurs were around for 160 million years or so before this. So your stegosaurs, your brachiosaurs, your allosaurs, a lot of these big deal groups showed up, spent tens of millions of years being successful and a big deal, and awesome. And then went extinct long before the end of the Mesozoic actually happened.
Yeah, it's often portrayed that like every type of dinosaur we know died off at the end of the Cretaceous, but many had their time and gone away before those Cretaceous dinosaurs ever showed up.
So it's depicted as essentially the opposite of Noah's Ark. Instead of every animal coming onto the boat, it's every animal going extinct at the same time.
Right. Well, if you think back to Fantasia,
it's
just all the dinosaurs are all together, and then they all die in the same event. But in reality, Stegosaurus and Tyrannosaurus never would have met each other. Stegosaurs were long extinct before the early things we'd recognize as Tyrannosaur cousins even showed up on the scene.
That's why you have all those memes of saying that like it's more accurate to show T-Rex on a unicycle than interacting with Stegosaurus because there's less time between those two. I've
seen so many of these memes of this is closer to this. I literally just looked up one that said Cleopatra lived closer in time to the building of the first Pizza Hut than to the building of the pyramids. I mean, that's wild, right?
That's totally wild, and it doesn't fit in my in the order of things that I have made in my mind.
Right.
That doesn't fit at all. That's wild.
Yeah.
But regardless of Cleopatra's first day working at Pizza Hut, what I was wondering is how some things made it through the event and some didn't.
That's always a really important question for extinctions.
This has been discussed quite a bit. Oftentimes we talk about it like, well, the dinosaurs all died, but then mammals, happily made their way across the extinction boundary, and birds, all survived.
Just skipped on through the fields of death.
Right. But of course that's not true, right? Most birds seem to have gone extinct.
Yeah, we almost lost birds.
We almost lost birds. And lots of mammals went extinct. There are some patterns that we observe in this and other general mass extinctions and extinctions in general, where certain things survive and others don't. One of the most obvious patterns is that the bigger a species is, and the more resources it needs, the more likely it is to go extinct when things get tough.
Yeah, those organisms do not tend to respond to change as quickly and need more specific requirements met.
Yeah, more
to
space,
survive.
more food.
Mm-hmm.
We see this today. Most of the animals in the world today, the famous endangered species that are in trouble because of habitat loss or pollution, those effects really hit big animals hard. Like if you think of a species alive today that's bigger than a human being, odds are it's endangered, because being big just means you have a really hard time adapting to ecological disturbance. So during the KPG, we see I've often seen it cited that nothing bigger than a house cat survived the extinction.
Oh, geez.
Generalists tend to do better than specialists. So if a species could only eat one particular kind of plant or could only live in one particular kind of habitat, those tended to go extinct more often than things that were less picky.
I think of it like picky eaters versus non-picky eaters on like vacation, that you're going to have a harder time while you're traveling around to new places and strange foods if you're a picky eater. But if you just eat anything, then you're fine.
All right, wait. So how did we get talking about dietary preferences?
Okay, so at the time, and granted, this was a late after work interview, but at the time, I thought it was on topic.
Okay, so you know what would be on topic? If you actually talked about what caused the extinction event. So let's get to it.
Yeah, it's funny. We did it. It took us a while, but we did get around to that.
Shortest answer, Big Rock.
Big Rock.
I want to say it's 6 kilometers, but it might be 10 kilometers and 6 miles might be what I'm thinking of. So
there you go.
6 miles / 10 kilometers. It means that this asteroid was about the size of Mount Everest.
Oh, right. Yeah.
And also that's about the maximum depth of the deepest parts of the ocean.
Mm-hmm.
So you could sit this asteroid on the average ocean floor, and about a third to a half of it would be above the ocean surface.
Yeah.
Oh, yeah.
This thing was huge.
That's pretty large.
Yeah.
Can't think of a thing being that big.
We have definitive evidence of a major asteroid impact that happened right at the boundary, right at the end of the Cretaceous. And in fact, in many places in the world, that boundary in the geologic record, right at 66 million years, you can actually see the boundary between the Cretaceous and the Paleogene, because there is this layer that is full of, when you look very closely and do chemical tests on it, full of meteorite stuff. It's full of meteorite dust, and it's full of elements like iridium that show up in high amounts in asteroids and in the dust that asteroids put off. Also includes a lot of what are called tektites, which are basically little formerly molten droplets of debris that came raining down all over the world.
It's like those little welding beads you get from metal coming off.
Yep. There is a massive crater buried underground. We can detect it by scanning the ground in the Yucatan Peninsula in Mexico, which is where the asteroid appears to have hit, which fits because the biggest evidences of impact destruction tend to be more severe closer to the Yucatan.
Okay. It hit in Mexico and longitudinally our part of the world. But these effects were felt all around the world, right? I mean, if you literally go 180 around the world, they're experiencing the effects of this strike. So what caused that? Because it wasn't the strike itself. There had to be some other sort of secondary effects or consequences.
Yeah,
that's definitely one of the biggest miscategorizations of the asteroid impact, is that it hit and it was like a missile strike and just killed everything.
We often talk about it that way.
Yes.
We say an asteroid killed the dinosaurs, and it sounds like it landed on all their heads and they all keeled over.
Yep.
But a mass extinction is caused by ecological disturbance. Right? The ecosystem around the world had the rug pulled out from under it. And I often think about the impacts, so to speak, of the asteroid as sort of three different timescales.
Mm-hmm.
You had immediate effects. So like hours and days afterwards, you would have had massive shockwaves, massive earthquakes, which would have caused landslides. We have evidence in the geological record of tsunamis washing up on shorelines around the world. And then you would have had, within the first few hours at least, raining debris spread for thousands of kilometers in all directions. Just the falling chunks of rock and formerly vaporized and re-solidified bits of rock. And these would have been very hot, so they also would have caused a heat burst in the atmosphere, which probably would have set off wildfires and been extremely dangerous for anything on the surface. And then, of course, anything in this crater space is gone.
It's just not a thing anymore.
It's vapor. So the first day or so is going to be directly, devastatingly damaging. And then in the years and decades after that, you would have dealt with the fact that most of the dust kicked up by the asteroid impact is sticking around in the atmosphere.
Yes.
It's hanging around up there in the sky, and it is predicted by models of asteroid impact and also by some geologic evidence that we have that dust in the air would have blocked sunlight, which would have not only led to short-term cooling, so global climate would have dropped for a while, but also that's really bad for plants.
Yes.
No sun means hard time for plants, which means hard time for herbivores and so on down the chain.
And even if it wasn't like a perpetual night, a notable dip in sunlight percentage has huge effects. Like it takes a lot less of a decrease in solar radiation reaching Earth to affect the plant productivity and temperatures than people might think. You don't have to actually put the shutters on and make it hard to see. A little bit of blocking dust would actually have a huge effect.
And that opaque dust, that dark dust in the air, would have lasted and had this impact for years and years and years. And eventually that would have cleared, and you would have been left with the fact that even after the dark dust cleared, that impact, especially hitting carbonate rocks on the surface of the Earth, would have pumped a ton of carbon dioxide into the atmosphere. And as we are very familiar with today, when you ratchet up carbon dioxide in the atmosphere, you lead to increased temperatures. So after this short-term cooling, there would have been a longer-term warming effect as that carbon dioxide was lingering in the atmosphere. So for probably hundreds to thousands of years after the impact, global climate was still out of whack, now in the other direction, and ecosystems around the world would have been struggling in the aftermath of all those earlier effects as well. So there would have been this devastating early consequences, these relatively short-term struggles, and then these long-term lingering effects. And once the dust settled, so to speak, lots of ecosystems and lots of species just didn't make it through.
Yeah, the really what just happened is the levels of chaos were increased exponentially, and ecosystems do not maintain well in chaotic situations. So as things were just constantly shifting and constantly changing, you're gonna lose players as they just can't keep up, or they get pushed out by others trying to survive, and it winds up killing off a lot just because things aren't as they were, or that species needed it to be.
And that has a cascading effect, right? If one species of plant goes extinct, then the things that ate that plant are now going to have trouble. And if one predator goes extinct, then its prey is going to expand, and that might impact other species. And so every time a species disappears or diminishes or goes extinct, that's going to have ripples across the ecosystem. So this was just rippling back and forth for probably millennia before recovery kind of started up again.
Do we have a sense of, like you said, it dipped relatively, the temperatures dipped for the short term and then increased dramatically over the long term. What was average temperatures back then? Were we talking about like temperatures now? Was it very different in these climates in which dinosaurs existed? What was it like?
That's a good question. I don't know the numbers off the top of my head. During the late Cretaceous, it was a warmer world than it is today. So basically anywhere you were in the world, it would have been warmer. There were polar forests during the Cretaceous. So even the poles were warm enough to support forest ecosystems. They wouldn't have been tropical forests.
That's still fairly lush.
Okay.
So it was a much warmer world than it is today. And then the dip and then rise again following the extinction event probably would have seen at least a few degrees change in either direction.
And that's, once again, is one of those where that's not as dramatic as people might have had in mind after we got hit by a giant rock from space.
Right. It wasn't 20 degrees.
Yeah. It wasn't turning the oven from mid to high.
Well, for a little bit.
Yeah, right? Yeah, for that second.
For a couple of days, it turned the oven to broil.
But a 2 degree in Fahrenheit or Celsius, whichever one you're using, but a few degrees constant change is that's a lot of energy that is globally the temperature is experiencing. So it doesn't actually take that much of a shift for ecosystems to be shocked by it.
Yeah, I feel like that is a good from a communication perspective, bad for human life perspective comparison to kind of what folks are looking at now with climate change. When we talk about a few degrees, it's like, oh, it's a few degrees. That's not bad. It's like it killed the dinosaurs.
Yes. Yeah.
Well, it's also worth considering that the peak of the Ice Age about 20,000 years ago, the last glacial maximum was, I think it's about 4 degrees colder than today. And Boston was covered in an ice sheet as thick as Antarctica.
Oh, that's wild.
Yeah, so it doesn't take a lot to create pretty major differences.
When you scale it up to a planetary temperature shift of that much, that's a lot of energy that you're losing or gaining.
Kind of puts present day climate change into perspective, huh?
Yeah, I'm really disappointed and worried about this, but I think, yeah, it is doom and gloom. There's nothing. We're doomed.
You're going through some feels right now.
I'm really having feelings. I don't even know. There's no words. I'm just half sentences here.
On the upside of this, or the potential upside of this, the dinosaurs didn't really have the capacity to do anything about it, where we do. So let's not like be too gloom and doom about it.
No, that's true. Oh yeah. Just gloomy,
yes, and real. We'll just real about it.
Oh, absolutely.
But in addition to the big rock that caused all this havoc at the time, that's the big thing, no pun intended, that was going on at the time. But it turns out there actually might have been other things going on as well.
So there were definitely other things.
Yes.
You know, this didn't occur in a absence of general change on Earth.
Yeah, it wasn't that things were just hunky-dory, completely normal.
One that often gets talked about is sea level change. This was a time period of dramatic shifting of sea levels, which meant rearranging of ecosystems, especially near the coast.
Currents were shifting when that happens.
So some researchers have suggested that that period of transition for some ecosystems may have left them a little more vulnerable than they otherwise would have been to a major disturbance. But the big one after asteroid that often gets brought up is volcanic activity. And this is actually, it's very funny because oftentimes you'll see artwork or movies depicting the age of dinosaurs, and there's always a volcano in the background.
Just puffing away.
And I think when we talk about volcanic activity associated with the extinction of the dinosaurs, I think that's probably what comes to mind for people, is like, you know, Mount St. Helens or Krakatoa sort of smoking in the background. But that's not the kind of volcanic activity that has been linked to this extinction event. We are talking about a type of volcanic activity that leaves behind what geologists call a large igneous province, which basically means an area of thousands of square kilometers, sometimes millions of square kilometers, of igneous rock laid down by consistent volcanic eruptions over thousands, sometimes hundreds of thousands of years. So when this asteroid hit, it hit during a time period where volcanic activity in India, which left behind a geologic formation we call the Deccan Traps, had been going on for many, many thousands of years and continued, it seems, for thousands of years after this. And all that volcanic activity would have been pumping out volcanic gases, potentially impacting the atmosphere, potentially impacting environments for a long ways in all directions. There's been a lot of discussion with the volcano and an asteroid, and sometimes it even comes down to, you'll see news reports that treat it as sort of like volcano versus asteroid.
Yeah.
Which one really did it?
Who's the true murderer?
Right. Which one's the smoking gun?
Yes.
And the reality is, it's very difficult to tease apart how important was one effect versus the other, because we can't, we don't have another Earth to experimentally test. Right? What if we hit it with an asteroid but without the volcanoes?
Yep.
Although we can model those things digitally. Generally speaking, as far as research today, most experts seem to agree that the asteroid impact was almost certainly the thing. It was the event that really tipped things over the edge. But there's been a lot of back and forth in research on just how important that volcanic activity was in perhaps weakening or exacerbating the struggle that ecosystems were going through at the time.
Yeah, it's a situation where had we been hit by the asteroid without those volcanoes, that volcanic activity, maybe there would have still been an extinction event, but it wouldn't have been as dire, or the effects would have been notably different, or like that's where the debate is how did that have an effect on the side effects of the asteroid, or would the asteroid have done what it did regardless?
Okay, it sounds like we're just talking about many different very bad, terrible things.
You're what is it? No good, very bad millennia, essentially.
Yeah. Yeah.
So yes, in this case, definitely. And frankly, in all cases, like all scenarios, regardless of whether it was all these things put together, whether it was probably just going to be one of these scenarios, dinosaurs were going to get the short end of the stick.
I'd say another one of the big ones, though, that I see get thrown around with this is that this is somehow an indicator of the flaws in dinosaurs. That this is a definitive of like, well, look, the dinosaurs didn't make it.
Clearly they were unfit to survive.
Exactly. They had their chance and they blew it. And it's often portrayed that this is somehow an indicator that dinosaurs were faulty. And the truth is that in all the groups that you think of as surviving it also still took major hits. And a lot like crocs come up. What we think of as crocodiles today hadn't actually evolved. Like the species we see today weren't around. And the group had just barely come around. So like it's not actually the crocs we have today were hanging around with dinosaurs and then just survived through. There were still tons of species that went extinct. There was a huge variety that we no longer have. And so it's not that the things that made it just made it through because they were superior. They happened to survive for a number of reasons, as did a bunch of dinosaurs in the form of birds.
Yeah, many of the things that survived the extinction event probably did because they had certain adaptations that allowed them to survive, right? They were more generalist, they were smaller, they were, they lived far inland where they avoided tsunamis or, whatever. And that is just as much adaptation to ecological disturbance as it is luck.
Mm-hmm.
A lot of the survivorship across this extinction boundary probably came down to luck. Dinosaurs like T-Rex and Triceratops and Ankylosaurus were extremely successful groups of animals. And oftentimes for millions of years, their groups were successful for tens of millions of years. The dinosaurs, in some respects, were actually doing better during the late Cretaceous than any time before during the Mesozoic era. So it's not like this happened and all the dinosaurs were just waiting for that last straw. Many groups were doing about as good as they had ever done. And this was an unlucky event for those organisms.
It sometimes gets portrayed that dinosaurs went stale, that they had hit a plateau, and this asteroid was what shook things up for mammals to take over. And that is so far from what all the evidence shows. That dinosaurs had not slowed down. They were not hitting the end of what dinosaurs could do. It just, unfortunately, space threw a rock at them, and they a lot of them did not make it.
Yeah, and it's easy for us to say on our relatively short timeline here on Earth that they were weak and just couldn't cut it when they were around for literally millions of years compared to how the thousands of years that go back to our ancestors, like we've been around for. Very different scales.
Yes.
I was going to say, easy to throw stones in glass houses. A little bit too on the nose there.
Throw stones in greenhouses.
Yes.
I love this image of dinosaurs being washed up and living in the past.
Yeah, I'm picturing Jerry O'Connell as Trip McNeely in Can't Hardly Wait. Do you remember this movie?
I do remember this movie.
So I'm specifically imagining this scene where he's sitting on this bench at a high school party, just being sad because none of the high school girls like him anymore, even though he's 25. Yeah.
Yeah. No, that's I was going to say, folks, Google it, but that is actually a fantastic summary. That's all the imagery you need. Yeah. Dinosaurs were not perpetuating the stereotype by any means. It would have been bad news no matter how quote unquote tough they were. It was not it was everyone's time except for a select few. And that's why we have what we have today, I guess.
Okay. Thanks, Trip McNeely.
Nice. All right. Well, that's all from Third Pod from the Sun.
Thanks so much to Shane for bringing us this story and to David and Will for sharing their work with us.
This episode was produced by me with audio engineering from Collin Warren.
We'd love to hear your thoughts on the podcast. Please rate and review us. And you can find new episodes on your favorite podcasting app or at thirdpodfromthesun.com.
Thanks all, and we'll see you next week.
I keep looking at your musical notes on the wall. Did you choose those?
Mm-hmm. Yeah.
It's really on theme. Is the rest of your house thematic in any way?
Actually, yeah. Our house is very national parky.
Okay.
Because that's our jam.
So no sad cows.
No sad cows. I'm trying to think if I ever. I'm sure I did something like that. I had that version. Oh, actually, I do have something like that.
You have a sad cow? Why do you have that?
Because it's silly. Look at that.
It is silly.
It's a frog with glasses. So we actually only have one bathroom in this house. It's actually one of the reasons why we got it for the price we did. There's just two of us.
Sure.
But in our old house, the one we rented, we had two bathrooms. So we had his and hers bathrooms. And my bathroom was
Frog themed?
It was herp themed. Yeah. So like it was my shower curtain was a giant, like was literally a salamander the whole way across the curtain.
Oh.
That thing was hanging up in there. I have like little like different knickknacks of frogs and salamanders and stuff from like indigenous tribes that are really cool that actually still are around somewhere. But yeah, so that's what that was.
That's nice. I like that. Oh.
Yeah, we're cute.
I'm learning so much.
You're gonna learn more.
I love it.